Okay, hello and welcome everyone. Thank you for joining us today. My name is Megan Weber. I'm an extension educator here at the University of Minnesota focusing on aquatic invasive species, and I'll be your moderator today. We are happy to be welcoming back actually Zhemek Bejer. Zhemek presented at one of our webinars about 2 years ago, we figured out. So we're really looking forward to the updates he has for us. Before I bring Zhemek in, I'm going to go through a couple of housekeeping items. So this is being recorded, so we'll have this available to view on our YouTube channel. So if you miss anything or want to come back and revisit something, have to leave early, don't worry about that. We'll have it up. It usually takes about a week for us to get the closed captioning done, and then we'll send out a link to everyone to come and view that. Our question and answer session is going to be moderated through Slido. So you can go to slido.com and enter the code CARP21, and you'll be able to enter your questions there and upvote questions as you go. You can enter your questions at any point while Zhemek is talking, and we'll come back to them all at the end. Next, let's see. Everyone will be muted for this session. So for the full question and answer, just go ahead and use the Slido. If you have problems with Slido or are having troubles getting there, that's okay. You can put your questions into chat. Pat Mulcahy is here to help as well. He'll be bringing those over and he can transfer them into Slido so that they still become part of the question and answer sessions. Also, if you have any technical issues, Pat's here to help with that as well. Just go ahead and type into chat and he'll assist with that. So I think with that, that's all that I have for housekeeping. So I'm going to welcome Zhemek, and Zhemek, feel free to take over the screen and start the screen share for your presentation. But Zhemek is presenting us today, and the title of his talk is Scaling Up Carp Management Through Automation and Citizen Science.
Yeah, so hi everybody. Hopefully you can see my screen and hopefully you can hear me okay. Let's see, minimize this. Okay, so thanks a lot for this opportunity to present the CARP webinar number 2 years after we did the first one. I hear that there is about a couple hundred people who signed up, which is great. So this one will be a little bit different than the first one. In the first one, I covered a lot about what carp are, what kind of issues they cause in lakes and all that stuff. And I will not be going over that in great detail. So if you want to look that up, you probably can go to the first webinar. This one will be a little bit different. This one will be more about technologies that have been developed and how they could be scaled up. So I am the owner and founder of Carp Solutions, which is a company that develops technologies for carp management and also manages carp. And I'm also an assistant research professor at the U of M at MASERC. So I wear 2 hats. And in fact, I have to start with the statement of conflict of interest, which basically says that I'm the founder and owner of Carp Solutions, a company that is involved in the development of management strategies for invasive fish, and these interests have been reviewed and managed by the University of Minnesota in accordance with its conflict of interest policies. Okay, so let's dive into the talk. So really basic things about carp. They're large minnow from Eurasia. They're not native to North America, introduced more than 100 years ago. And again, I'm only providing really basic facts for this webinar. Carp are called ecosystem engineers because they can have profound effects on lakes, especially shallow lakes. If you've seen my talk before, you probably saw this video. The carp dig in the bottom looking for food. They can release nutrients from the bottom, increase water turbidity, and have negative impacts on biodiversity, aquatic plants, waterfowl, etc., etc. We also know that by managing carp and fish in general, we can restore lakes, improve water quality. This is just one example from Pickerel Lake in Minnesota. This effort was done by Shell Rock River Watershed District and was recently published by Brian Huser. This is a shallow lake close to Albert Lea in southern Minnesota. In agricultural area where the watershed district was able to totally eliminate carp by poisoning the lake And you can see the before and after changes in total phosphorus, a decline from about 0.4 milligrams per liter to less than 100. And this is about as dramatic as it gets. Not all lakes respond in this manner, but usually there is a significant effect after the carp are removed, again, especially in shallow lakes. So I have this in red font, no change in land use. So who is the driver of water quality, fish or land use? Because again, this is an agricultural area. There have not been significant changes in land use that I'm aware of the last several years, but yet the water quality improved, suggesting that fish can be important drivers of lake restoration. Carp dominate lakes primarily in southern Minnesota. We tried estimating that a few years ago, and we estimate that about 70% of lakes in southern Minnesota are impacted by too many carp. And this is coincidentally where we have issues with excessive nutrient concentrations. Okay, so now I'll be talking about developing new technologies for carp management. So I should mention that there is one already existing technology, that's winter seining, that is being used by commercial fishermen. And I did talk about that in my first webinar, so you can go back and look at that. Basically, winter seining is using large nets under the ice to remove large numbers of carp, because carp tends to aggregate under the ice. So that technology has already existed for decades. But we will be talking about developing two others that can be used not during the winter time, but during the summer, and then during the spring and then summer. So this is the springtime, the first one. So I'm going to show you this video, and it's about maybe 2 minutes or so long, and then I'll explain. So this is about using an electric guidance system to remove carp during spawning migrations. Carp are migratory fish in a lot of systems, and in May and June, they move in large numbers from lakes to marshes, and that creates a good opportunity to remove those fish. And we developed this technology to deal with that. So we are at Rice Creek in New Brighton, Minnesota, and we're doing a field test of a new technology for removing invasive carp, common carp, in the stream. Okay, so hopefully you're still with me. That was a condensed version of what we are trying to develop. And if you want to watch it again, I guess you can do it here again, or you can go to our YouTube channel to see it. Um, um, but basically, we're exploiting a natural behavior, the tendency of carp to migrate to, and using low voltage electric guidance system to guide them into a trap. And then we're also using mild electric fields to aggregate them and then eventually remove them. So the idea is in the long term to develop technologies that are, I'm not going to say are hands-free, but require less labor than maybe traditional carp removal methods. So here are the results, and this is in Rice Creek. The blue bars show how many tagged carp were migrating every day. So the migration started in mid-March and ended in late May. And the number of tagged carp that were approaching the electric guidance system or the electric barrier, because they cannot really swim through it, is shown on the left-hand side. So these are from 0 to 500 uniquely tagged carp per day. And the number on the right-hand side shows actually how many were caught in the trap. So you can see right away that the carp were migrating pretty much throughout, and they were trying to cross this barrier on a daily basis, but only every once in a while they would go into the trap in large numbers. Those are the yellow bars. In fact, in 2 days we collected about 2,000 carp on each day, but on other days the catches were much smaller. But all in all, we had about 500 of those tagged carp that were detected at the electric barrier, and we removed overall 10,348 carp. And then because we have those tagged carp in the stream, we can do mark and recapture estimates. In this case, we scanned over 6,000 carp to look at the ratio of tagged carp to non-tagged carp, which was about 3.7%. So about every 30th carp was tagged. So we estimated the entire spawning run at about 13,500 carp, which suggests that we removed over to 70% of the fish that were attempting to migrate. We're in the process of sort of doing the final analysis and writing this up. So this 76% number is not set in stone. Like in the video, we showed 65, but it's going to be a large number somewhere in that range, which was actually quite significant. We also learned a lot about the carp behavior. The carp were challenging the barrier for multiple days, on average, almost 10 days. So an average carp would show up at the barrier on 10 different days that spring. And only during some of those days, they would swim into the trap in large numbers. We probably not very professional are calling it a swarming behavior for a lack of better word, but this is what it looks like when they eventually decide to go in the trap. So at this point, the electrodes are turned off. We are letting them aggregate inside the trap. So these are the crowding electrodes inside the trap that they're normally turned off. But you can see just the density of the carp in the trap, and they're totally oblivious to us being on shore and filming them. So this is kind of an interesting behavior. It would be good to understand exactly what's driving it. Because again, on many days, they'll be trying to go in the trap, but only during some days they actually do. So that was the first technology, removing carp during spring migrations. The second one is used in the summer. And this one uses the fact that carp are social animals and they can be trained to aggregate using bait, in this case, cracked corn. So for that one, we are using what we call box nets. These are usually 60 by 30 mesh nets with the bottom and 4 sides and open top. And they're designed so that the sides can be quickly lifted above the surface using counterweights and trigger devices to catch the fish that are aggregating inside. So once we install those nets, we start baiting them. And then once the carp are trained, we catch them. And this is So it's a relatively simple concept. This shows how the nets are lifted to catch the carp. This one is a test right after we set the net, so that we're not baiting it yet, so there are no fish inside, but I just kind of wanted to show you how it works. So the guy, I'm standing by the trap filming it, and the guys are on the boat, and they will be releasing the net or triggering the net using a remote controller. So you will see that once they trigger it, the sides of the net will come up. So the counterweights are sliding inside those plastic tubes for safety. And the trigger releases the rope and the weight falls down and the net comes up. So it's a pretty simple concept. It's important to be able to trigger them from a distance because we don't want to spook the carp. And this is a video of carp feeding underwater. This was taken by Peter Hunt in Long Lake a couple of years ago. This is to show you how selective the corn bait can be, because in this video, all the fish that you see are carp. And we see that very commonly when we remove carp with this method. I'll show some results in a second, but usually the bycatch, which is fish other than carp, are less than 1%. So once you start baiting, after a few days, you end up with a big swarm of carp. And we use, again, pit tags, which are those microchips, like the ones that are used in cats or dogs. Before we start removing the fish, we implant usually a couple hundred in the lake and release them. And we put a pit antenna around the bait. So when the carp show up to feed, that information is stored by the detected by the computer, and then you can go online and watch it. So this is a data from Long Lake from last summer. We're looking at about a week worth of data, and we're looking at unique tags detected per hour between August 24th and August 30th. The gray bars are nighttime, and the white ones are daytime. And so, for example, on August 24th, you can see that there was up to 8 carp detected per hour. And in this particular instant, they were detected at about 10 a.m. So it was kind of interesting. The next day, most of them were detected at about 6 a.m. The next day, most were detected at 3 a.m. So you can see the pattern that we kind of see what's the maximum detection for this net is about 8 to 9 fish per hour. But the time when they aggregate can vary from day to day. So it's important to be able to watch that in real time to decide when to activate the net. And then I think we caught these fish, and then usually after you catch the fish, there's a few days when they don't want to come back to the bait. But in this case, after 3 days, they started coming back again, so you can repeat the removal cycle. So this is what it looks like when the carp are actually feeding. So we just got the data that there should be a large number of carp in the net, and one of us is on the boat triggering the net remotely. Now the weight's dropped and the net's coming up. It takes a second for the fish to figure out what happens, and then they start jumping, trying to escape. But at that point, it's too late because the net's already up. And then once all the nets are triggered like that, the crew shows up with a big boat to remove those fish. And in the distance, you can see the solar panel with the data logger that collects the data from the pit antenna that's inside the net. And here are some results. So we tested that in many lakes, but I'm showing results from Long Lake. In New Brighton, So keep in mind that in the spring of 2021, we removed 10,300 carp during the spawning migration. This is the summertime removal in the same system. So this is Long Lake, and the stream flows through here, and the electric battery is just north of the lake. But in any case, this is the removal results from the box nets. Summer 2020, we installed 6 nets in the lake. These are the yellow rectangles. And the nets were pulled or lifted on 2 different occasions. And here are the results. So the nets were lifted on September 25th and October 9th. The first time we caught 2,600 carp, and the second time 4,200. So almost 7,000 carp combined. The bycatch was only 3 other fish, which were released. So again, extremely selective removal method for carp. We did another run in this last summer 2021. In this case, we only installed 4 nets, but they were lifted on 8 different days. But I made a comment here, smaller crew. In 2021, we had a smaller crew on site. And this is kind of a nice thing about those nets, that if you have multiple nets in a lake, and if you have a big crew, you can go and lift all the nets in one day and remove the carp in one big swoop. But if you have a smaller crew, you can do a couple nets in a day, just to kind of manage the effort. So in this case, we lifted the net on 8 different days, but not all nets were lifted on every single day. And here are the results. So you're seeing the dates, and this is just the total number of carp that were caught. And overall, there were 6,162 carp that were captured. The bycatch was only 20 other fish. So again, very, very low. And because these nets are non-lethal, the bycatch can be easily released. We also ran some population estimates. So between this springtime removal with the electric barrier and the summertime removal with the baited box nets, we removed over 26,000 carp from that system from September 2020 through October 2021. So that's about 120,000 pounds of carp. That's a lot of carp. But we still estimate there's about 25,000 carp remaining in the system. So we removed just a little bit over 50%. And the goal for 2022 is remove 20,000 carp, at which point the system should be restored. The carp should not be impacting water quality in that system anymore. We also observed interesting data when we looked at the lengths of the carp we caught in the baited box nets versus the stream. The stream is the EGS, is the electric guidance system. So the box nets are red and spring removal is blue. And you can see that during the spring, we're catching both large and small carp. But in the summer with the baited box nets, we're primarily catching small carp. So that was kind of interesting. We'll see if that pattern continues next year. So in summary, we have 2 automated, or at least semi-automated, selective technologies for carp that have been developed, and they complement the existing technologies such as winter seining, so that now you can think about integrated pest management strategies where you have 3 different removal methods, one that can be used during winter, one during the spring, and one during the summer. And one thing about that is it's good to have methods that can be used year-round if you're thinking about using carp biomass for something like fertilizer production, for example, because for that, you usually want a steady supply of biomass. So it's nice to have a method that different methods can be used year-round. I also think that the future automation will accelerate, as probably with any technology. Once you have a good working prototype, it's much easier to improve it, and that's certainly our goal for the future. But what we already have works quite well. Okay, now I'm gonna switch gears a little bit and share with you some thoughts I have about carp harvesting and lake restoration and whether that can be sustainable. And keep in mind that I'm a guy who's running a carp company, so I may be biased, but I hope that this at least stimulates some discussion and maybe some more thorough analysis. In any case, a few years ago, my grad student, Joey Leckelt, published a paper that kind of looked at how many carp you would have to remove from a typical lake in southern Minnesota, which is very productive, to control that population. So without going into too many details, the top row of those three graphs basically shows do nothing scenario. So those populations stay very abundant at about 500 to 700 pounds per acre or kilogram per hectare, which is commonly what we see in those lakes. What you want is you want to reduce those populations below 100 kilograms per hectare or pounds per acre, which is that black kind of line you can see. And on the left-hand side, you can see the percentage of fish, carp, that is removed annually from the system. So this is 0, 30%, 50%, 60, 70, 90%. Long story short, you can see that once you apply 60 to 70% removal, these populations should be staying below the management, below the management threshold, which is here. So 60 to 70% of carp need to be removed annually or almost annually to keep their biomass low. At least that's what our data suggests. So how would this work? So let's use a 1,000-acre lake in southern Minnesota as an example. So the starting biomass, like I was saying, is usually in the 500 pounds per acre range. The biomass that would need to be harvested, say 60% of that annually, that's about 300 pounds per acre. So in the whole lake, that's 300,000 pounds of carp annually, or about 75,000 carp. That's a lot of carp. And annual cost of that, and again, this is just based on my experience looking at how much it costs to harvest carp. I would guess that about $3 per carp, or about 60 cents a pound, is achievable. So that's 225,000 per lake. And a crew of 6 people can get that done. And to make it sustainable, they would have to have about at least 2 systems like that per year. So about $450,000 to $500,000 to make a crew of 6 and overhead, basically make that sustainable. Okay, so this is the cost, right? About $225,000 per lake. What are the benefits? Well, one thing about removing fish is that fish are pretty high in phosphorus. And phosphorus is the nutrient that we're trying to remove from the lakes. About 0.5% of wet body weight of carp is phosphorus. So if you're removing 300,000 pounds per year, that's about 1,500 pounds of phosphorus removed with the biomass. So the cost per 1 kilogram of phosphorus is about $300. Keep that in mind, because in a second, we'll look at how that compares with other lake management costs and benefits. Now, this is just with the carp biomass, the phosphorus that's in carp biomass. But as I showed you at the beginning in Pickerel Lake, usually when you remove this many carp, you also see a decline in phosphorus in the water column. So here I'm assuming a very modest decline of 30 micrograms per liter. And so that would add about another 260 pounds of phosphorus per year removed. And again, this is not a high. 30 micrograms per liter is actually quite moderate. But in any case, this additional phosphorus removed brings the cost down to about $280 per 1 kilogram of phosphorus removed. Then keep in mind that you'll be harvesting a large biomass of carp, which potentially could be used for example, for fertilizer production. And even if that was only 10 cents a pound, then we're talking about $30,000 in savings in that. So the cost now drops to about $240 per 1 kilogram of phosphorus removed. How does that compare with other phosphorus removal strategies? Well, this is an analysis by Bill Bertoggi from Ramsey, Washington Watershed District. And this is a metro watershed district, so it's not necessarily representative of agricultural watershed districts, but you get the idea. So this is the cost, the first column with numbers of the cost in US dollars per 1 kilogram of phosphorus removed. So remember that the carp was in the 240 to 300 range. Well, the cheapest one that they found was about 480 per kilogram with alum injection, or 670 per 1 kilogram of phosphorus removed with harvesting aquatic vegetation. And by the way, to do either of these, you have to control carp to start with anyways. And then when we look at the best management practices, such as alum injection into stormwater ponds, iron-enhanced sand infiltration, and other things, then the costs go into thousands of dollars per 1 kilogram of phosphorus. So, my sort of back of the napkin analysis suggests that even if I am substantially off, there's still pretty good margin of error where carp harvesting could be used to create essentially sustainable economy. There are also other benefits, such as better water quality, which is, the main goal, really. Local jobs, soil health potentially improved. I don't know if you followed the data, or, I'm not a farmer or an agronomist or a soil scientist, but you hear about the negative effects of using a synthetic fertilizer on soils, and fish fertilizer is known to be quite healthy for soils. Native biodiversity increased. Just one example is waterfowl. It's well established that carp control increases diversity and abundance in waterfowl and other organisms too. And we're actually talking about nutrient removal, not what many other strategies do, which, like alum injections, for example, which keep the nutrients in lake sediments, but they don't actually remove nutrients from the system. And so let's take a look at the amount of funding that's available in the state for broadly defined efforts to improve water quality. And this is really, really broad. This is not just lake restoration, but land management practices, cover crops, all that stuff. So clean water, most of that comes from the Clean Water Land and Legacy Amendment, and that's about $260 million a year. There are also other sources of funding, such as watershed districts, which is the from taxes for real estate properties. So if you do the math, and if you remember that, a reasonable cost for lake management to remove carp was about $225,000. If my math is correct, for about 10% of what's available for, again, these large, broadly defined funds to improve water quality, for about 10% of that, you could restore or control carp in 115 lakes that is 1,000 acres in size each. That's a lot of 1,000 acres lakes in Minnesota. I don't even know if we have that many. The point is that you could do a lot with some of those funds. And currently, as far as I am aware, there are no carp management programs in the state, meaning that money is not being used for carp management. And I'm not saying this, the funds that the program that this money is funding are very, very important, such as cover crops and reducing nutrient runoff from land into waters. But what I'm suggesting is perhaps this would warrant some analysis to see if some of this could be used for carp management and carp management programs. Because we do know that carp management in shallow lakes often does have, positive, tangible results. And on the other hand, if you manage land intensively, but don't do much management in lakes that are filled with carp, the efficiency of those best management practices on land may not be optimal. Okay, well, this is really all I have. And I need to thank the entities and funds that were funding my research at the U of M, ENRTF, MASERC, and most of the results were all of the results were from Rice Creek Watershed District, so I want to thank them. And also, if you want to follow us on Facebook and YouTube, we have many additional information or videos if you're interested. So let's see, sounds like we have, we should have enough time for questions. Yeah, 1:36. Okay, well, really that's all I have. So I'll be happy to answer questions.
Great, thank you so much, Zhemek. We do have some questions coming in. I am going to take over the screen again quick to just go over the Q&A one more time before we get started. So showing on the screen now is how you can access the Q&A. So you can either use like a phone or tablet or smart device and scan that QR code, or go to slido.com and enter CARP21, and that will get you in. You can either ask your own question, you can upvote the questions that others have asked that you'd really like to see the answers to in case we don't have enough time for all of them. And if you do have problems with Slido, that's okay. Again, you can just put your question in chat and Pat is here to help, and he'll make sure that those get over into Slido so that they become part of that Q&A. So Zhemek, I will go ahead and get started with the questions that have already come in, as I'm sure more people will wander over and start to ask their questions. But your first one was wondering what the correlation is between common carp and increased nutrients like phosphorus. Is it just from the sediment disruption, from the foraging behavior, spawning? Is there like a defecation component or something else that's leading to that?
All of the above. We don't really understand how the different activities contribute to increased phosphorus concentrations in lakes dominated by carp. Some of the old papers, like Lamara's papers from 1970s, were trying to tease those apart, but I'm not convinced that they did. What we do know is that what happens in lakes when you remove the carp. And there are several examples of what can happen. The Pickerel Lake that I showed, it's pretty extreme. I mean, they did see about three time decline in phosphorus. In other lakes, you sometimes see less dramatic responses, but they're pretty significant. There's Lake Casey, which is a small urban lake in the metro area. They also did see, I think, at least two times decline. In some deeper lakes, we see less change in terms of phosphorus. We are actually trying to pull all of those data together to write a paper that would kind of show, how the carp impact different lakes and different types of lakes. Kind of convoluted answer.
That's great. Thank you. Okay, let's see. The next question, and I think there's a couple that, or actually what I'm going to do is I'm going to merge two questions together. One was wondering what the method of euthanasia is for the fish once you capture them, but then coupled with that is what the uses are for the dead carp and how you're disposing of them now.
Right. So we euthanize the carp with clove oil. It's a clove oil solution in water, and as soon as the fish are harvested, they are transported to a large containers with clove oil, and they're euthanized that way. What we use with the carp, we don't have commercial license to do anything with carp biomass. So we can either bury them or incinerate, which is kind of weird, but they are basically, they end up in the ground. We don't do anything with them. We cannot. It would be great if we could. Oh, and I also say that whenever we work or wherever we work, the carp are first offered to local commercial fishermen to see if they have any use for them, but usually they don't.
All right, great, thank you. The next question was wondering about the paper that you showed early on in the talk that had the phosphorus reduction with the carp and bullhead removal. I think this was on Pickerel Lake, and wondering if you had the name of that paper or where it was published, so that they might be able to find that.
Yeah, that was the first author was Brian Huser. I think it was published in Inland Waters last year.
Okay.
And if you cannot find it, just email me afterwards.
Sounds great. And I think I might have that up. I was trying to search for it while you were still talking, just in case. And I think I do have that one up there, but wanted to be sure I had the right one before. So I'll try and throw that link into the chat as well for that paper. Okay, the next question is wondering about if goldfish have some similar patterns to what you're seeing with the carp or behaviors, so that some of these same tools and techniques that you're using for carp removal might be useful in dealing with some of the large goldfish populations that we're also seeing.
I think yes and yes. Well, goldfish are obviously much smaller than carp, but they have the same feeding behavior. They are feeding in the bottom. I'm trying to see to remember if there's any papers on the effects of goldfish on ecosystems. Goldfish have been sort of becoming, well, quote unquote, quote, more popular in recent years, both in terms of management and papers. I'll have to look through the papers if there's anything, but I would expect them to have similar effects, maybe a little bit less substantial because they cannot dig into the sediment as deep as carp can. And whether the same methods could work, I think so, because they have the same diet. They're social animals, so for sure, the baited nets should work. Whether the spring migration methods would work or wintertime removal, that I don't know.
Great, thank you. Okay, our next question is wondering if you're aware of any studies that estimate the amount of total phosphorus that carp can resuspend into the water column that helps get an idea of what those reductions by carp might be, rather than just the focus on a biomass.
Right. Well, also Pickerel Lake is one. There were some papers from Ventura Marsh in Iowa. That was John Downing's group did that research some time ago. They did see a phosphorus decline after carp removal from the system. I don't remember the numbers off the top of my head. And like I was saying, we're trying to pull together those different examples from those case studies to kind of document, the declines in phosphorus. So Lake Casey, that was Bill Bartagi's work, was close to 100%, meaning the phosphorus halved after carp were removed. And none of that includes the biomass that were removed with the carp. That only looks at how phosphorus concentration changed in the water.
All right, perfect. Okay, our next question is, how does recruitment impact the population estimates and the impact of your annual removal efforts?
Good question. So the annual removal that I showed, this is for the worst case scenario. This is a lake in southern Minnesota where recruitment happens every year. It's a carp factory. And that's kind of often the case in those lakes because, in other lakes, like in central Minnesota, we have bluegills and other fish that are controlling carp reproduction. But in those lakes in southern Minnesota, often we don't have stable populations of bluegills and native predators because there's winter hypoxia or summer hypoxia. So not much is controlling carp recruitment. So that was my assumption. So that was like the worst case scenario, that there will be a recruitment every single year. And the more adults you remove, the more babies they have per individual adult that remains in the lake. So again, this is the kind of challenging scenario. If we were to use that in lakes, like in the metro area, the cost of management would be much less and the frequency would be much lower, because in those systems, sometimes you just, you need to remove them once every several years, and their population will remain low. Peter Sorensen wrote the paper on that last year, kind of summarizing some of those efforts in the metro area.
Perfect. Okay, next question was going back to the EGS treatment and wondering if you had mentioned if there's any bycatch that happens with that removal method, and also if there's any interference with movement for other species that might be trying to access spawning grounds.
Yes, good question. There is more bycatch than with the baited nets. In Rice Creek, we had about 200 fish that were other than carp, largemouth, northern pike, bowfin. There's a lot of fish that migrate. So what we do when we go through the trap, we release those fish upstream so that they continue their migration. For small fish that are migrating, the system is designed such that these, like bluegills and crappies and even bullheads, they can go right through our trap because the spacing between the bars in the trap is such that they can just swim through. But for large fish, yes, their migration would be affected. If we are able to increase efficiency of carp removal, maybe we don't have to run this system for, say, 2 months like we did last year. Maybe we run it only for a month or a few weeks, in which case the migration of native fish would be impacted for a shorter amount of time, or we continue, just sort them by hand and release them upstream.
Great. All right. Going on to our next question. This one was wondering about a different project and if that's still being looked at with using a fish poison in a corn bait tool, and if that's something that's still being looked at, and what that might be as far as impacts in relation to perhaps their rodent-owned treatments.
Yes, yeah. So we ran a couple experiments with that in the lab and in ponds in La Crosse at the USGS facility. It does show promise, meaning carp will eat it and they'll die from it. It wasn't 100% effective. I think in the ponds we achieved maybe 40% or so efficiency, meaning not all the carp either ate it or died from it. That could be related just to the dose or non-even distribution of the bait among the carp, meaning some carp show up first and eat a lot of the bait, and then the others kind of don't have anything available. Simple explanations. We decided not to pursue that because if you can remove the fish that aggregate in at the bait with nets rather than with poisons, maybe that's a better way to go for a couple of reasons. One is, you're not applying poisons in lakes, and B, you can actually use the harvested fish for fertilizer or something like that.
Sure. Great. Okay. The next question is wondering about your box traps, and are they something that are sold or rented, or how does that work for someone who's wanting to implement something like that?
I suppose all of the above. So the particular system that we have is patented, but we work with watershed districts or lake resident groups or other companies through different licensing options, or people can just hire us to remove the fish. But really, that's actually a good question, because the reason why Carp Solutions exists is our really main focus is on developing technologies that others can use. So we definitely have mechanisms for others to use those technologies. Licensing would be one example.
Okay. Wonderful. Okay, and then at some point you had shown a figure showing the reduction of carp abundance when you're achieving that 60% removal. But notice, I think that they noticed that excluded the smaller fish, so it was looking at juvenile or young a year. Do you have any methods that might target some of the smaller fish then as well?
Yeah, good question. Well, so for sure the baited nets would target them. You just need to use smaller mesh. And actually, we ran into that in one of our projects where we were harvesting both the adults and young of the year. So that can certainly be done. Springtime migrations, not so much, because those young fish don't migrate. They start migrating when they mature. And in terms of late season, wintertime aggregations, perhaps. I don't really have much experience with that in terms of, how the small carp behave. Possibly, but the baited nets should work for sure.
All right. And then who do you think the decision makers are in regards to adding carp management as one of the best practices for improving water quality?
Well, so we had some discussions with the Clean Water Council as to whether there maybe is time for doing a pilot project or test in a lake or a system of lakes to see whether this what I'm talking about really makes sense, and how this could be done in like in real life. And I think that would probably be the best way forward, just to continue those discussions.
Okay. The next question is going back to the box nets and wondering about how or if you're training the carp at the feeding stations. Does it work right away? How long does that take? How are those working?
It takes about usually 4 to 5 days, and they're trained, and then you can remove them. And then you give them a couple days break, and then again 4 to 5 days, and you can remove them again. So every season you can do multiple cycles, every summer and fall.
Great. Okay, and I think I'm going to transition to a different question that's maybe a couple down from there, but I think relates. So once you have them in that net and you've been training them, how are you getting them out of the net afterwards? Are you having to hand dip out of the net, or are there ways to automate that process as well?
Yeah, I didn't really have time. No, that's actually the easiest part of dealing with them. And if you go on so there's a link to our YouTube channel on the last slide. You can see that video, exactly how it happens. Basically, what we do is we use a floating boom that we put underneath the net, underneath the bottom, and we drag it across the net to squish all the carp in one end of the net. And then we have cranes on the boat. The boat is parked along the short side of the net, and the cranes are hooked up to the bottom of the net. And they're basically all lifted into the boat in one swoop. So that is the least time consuming process. That's the easy part.
Great. And I did just throw the link into that YouTube channel so that anyone who's interested in seeing the videos there can find those. Okay, we have about 7 more minutes. We can probably get a couple questions in before it's time to wrap up. Next one was wondering if you've conducted any experiments either in the lab or the field on the effectiveness of the electric barrier with trap for either silver or big head carps.
No, we haven't. I have not done any project on those fish, any projects. It could certainly be I guess it would be an interesting experiment. Watching how the common carp react to that barrier, it was very interesting. And then we actually published a paper on the effectiveness of the barrier for common carp during spawning migration. The fish were trying to cross that system very, very aggressively. I mean, they would try to jump over it or swim through it. But the system is designed that it doesn't paralyze the carp, but it basically makes them turn around. So they swim in between the 2 rows of electrodes, and they're turned back. And I think this would be sort of my general comments to studying the effectiveness of fish barriers in non-natural settings. What I'm trying to say is, I would be very interested in studying this technology in a natural stream using naturally migrating silver or big head carp that are very, very driven to reach their spawning sites, because I think that that's really the best test of those technologies. And my experiences with common carp in the system, seeing how aggressively they tried to cross it and they were not able to cross it, suggests that this would probably work for, the big head or silver carp. The system has some pluses and minuses. For example, it probably couldn't be used in like a lock and dam situation because you have metal electrodes that are sort of standing up vertically, held by floats in the water. So if you have barges moving through, that may not work. But in a lot of the situations where you don't have a heavy boat movement, I would be surprised if this didn't work.
Perfect. All right. And I think that likely leaves us time for one last question. So this one is wondering if it would be less expensive to operate a standard physical trap that goes across a spawning creek for up to 2 months and just going in to release native fish every day with a couple of people on a crew.
We tried that, and I am not trying that again. running, well, that could be done in a really, really small stream that's really easy to maintain. And we often do that. In a small stream, we just put a physical barrier. And when the carp aggregate, we go in with an electrofishing backpack. We get them out that way, and it's fine. You don't need any fancy technology. But in the bigger streams like this one, which is about 60 feet across, a physical trap, in my opinion, absolutely impossible. Just the amount of maintenance that it takes to keep those, the physical screens clean and free of debris, it would be extremely substantial. And I don't even think it would hold up to just the amount of water that flows through that system. So this is kind of nice because it's non-physical. The electrodes are in the stream. They don't collect much debris. Like, we don't clean them for months. And they just, gently guide the fish into the trap, which is to the side, away from the main current. And it's kind of easy to maintain and easy to operate.
Wonderful. So I think that leaves us with 2 minutes, and I'm going to take those up to do our final housekeeping item. So I'm going to advance this slide here. And first, give my thanks to you, Zhemek, for coming and sharing with us again. It's been great to hear your updates and how things are going. Also, thank you to everyone who joined us live today. We appreciate you coming and listening in. We did record today's session. You'll be able to find that on our YouTube channel. You can get there by going to z.umn.edu/AIStube. And you'll be able to find this one there in about a week. We'll send a notice out when it's ready, as well as all of our past webinars, including the one from Zhemek about 2 years ago. If you have questions, I have Zhemek's email showing on the screen now. I think he said he's open to people reaching out. So if you have any further questions for him, feel free to shoot him an email. If you have any questions for us about the webinar series as a whole, other programs, you can reach us at AISdetectors@umn.edu. With that, I'm going to wrap up. You will be getting a notice. I think it might pop up on your screen when you close out, but also you'll get one in email shortly after the webinar ends to our evaluation. So we'd appreciate you taking time to answer a couple questions about what you thought of today's webinar. And that is all that we have for today. So thank you again, Zhemek, for joining us. We really appreciate having you.
Yeah, thanks a lot.